Ever wondered how computer algorithms are optimized using calculus? It all starts with understanding the concept of limits. In the fascinating world of calculus, limits are a key player, and they hold significant importance in computer science. Especially when it comes to optimizing algorithms, the knowledge of limits proves to be invaluable. Simply put, a limit represents the value a function approaches as the input variable gets arbitrarily close to a specific point. So in essence, limits help us predict the behavior of functions at specific points. Now that we have a grasp of limits, it's time to dive into the algebra of limits. The algebra of limits is an essential tool in the world of calculus. It's about manipulating expressions involving limits using standard algebraic operations. Think of it as a set of rules that guide how we handle limits in various mathematical scenarios. It's like knowing the grammar of a language, which helps us form coherent sentences. Similarly, the algebra of limits helps us simplify complex functions and determine their behavior at critical points. It enables us to break down complex expressions into simpler, more manageable parts, much like how we break down a complex sentence into simpler ideas. This skill is significant in understanding the behavior of functions as they approach specific values, a cornerstone in differential calculus. The algebra of limits, therefore, is a key tool in making sense of complex functions. Understanding the laws that govern limits is crucial for any computer science student. Let's dive right in. First up, the sum and difference law. The limit of a sum or difference of functions is the sum or difference of their limits. For example, the limit as x approaches 2 of the sum of 3x squared and 2x is the sum of their individual limits. Next, the product law. The limit of a product of functions is the product of their limits. For instance, the limit as x approaches negative, 1 of the product of 2x squared and 4x equals the product of their individual limits. Moving on to the quotient law, the limit of a quotient of functions is the quotient of their limits, provided the limit of the denominator is not 0. Finally, the constant multiple rule. The limit of a constant times a function is the constant times the limit of the function. With these laws, we can confidently simplify expressions and evaluate limits. Mastering the algebra of limits is more than just a mathematical exercise. It's a key that unlocks advanced aspects of computer science, specifically in optimizing algorithms. By understanding how to manipulate and evaluate limits algebraically, you can scrutinize the behavior of functions, making them work more efficiently. This knowledge isn't confined to the classroom. It's a tool you'll carry into your professional journey in computer science. So keep exploring, keep learning, and remember, the power to optimize algorithms lies in your understanding of the algebra of limits.